Today we're going over lines that intersect a circle, arcs, and chords. So I need you to remember that interior means inside and exterior means outside. This still applies with the circle. So anything that's inside the circle is interior. Anything that is outside of the circle is exterior. So a segment that has endpoints on the circle itself is a chord. A line that intersects a circle at 2 points, meaning it goes through the circle, is a secant. And a line that touches the circle at 1 point is a tangent. The point where the tangent and the circle intersect is the point of tangent C. So our first couple sets of examples are using those definitions. So we want to identify each line or segment that intersects circle A. First off, we're looking for chords. So chord is any segment that has endpoints on the circle. So the first one we've got the segment BC. We do have another one. Even if it doesn't look like it, we have another one because E and F are on that ends of the circle. And there is a segment there. So if you type your answers in on a computer, you need to write out segment and capital letters. These should be capitalized. They either need that bar over top or segment, word segment in front. A diameter, remember, is a chord that goes through the certain center of the circle. So that is also segment BC. And then we're looking for a secant. So secant is a line that goes through the circle. So that would be line EF. So if you're doing this on a computer, you do need to write the word line. If you are just handwriting it, you can use the symbol for line instead. Radii or radius, if you're doing singular, starts at the center of circle and goes to sides. So we don't just have one here, we have two, segment AC and segment AB. Again, if you are using a computer to write out the answer, you have to write the word segment and then the two letters capitalized. Then we're looking for a tangent. So tangent is a line that intersects a circle at 1 point. And in this case, that is line L. I can't do line CL because L is a lowercase cursive letter that names the line, not a capital letter that would name a point. Next example, same thing. So chords, that would be a segment CE and segment AB. Diameter is the chord that goes through the center of the circle. This is segment CE. Secant is a line that goes through the circle. So that is line AB. And radii start at the center of the circle, go to the side. So segment DE and segment CD. And then the tangent is the line that intersects the circle at one point, and that is the line EF. Our next example, we want to find the length of each radius, identify the point of tangency, and write the equation of the tangent line at that point. So first off, radius of circle A. So we go from the center of A to the side of the circle, doesn't matter which direction you go. And that is 4 units. Radius of circle B, again, from the center of the circle, going to the side, doesn't matter which way you go, it's 2 units. Point of tangency, so it's where the circle and the tangent line intersect, which is right here at 3, 0. Because we went 3 from the origin to the right and then stayed put on the x-axis. Then we want the equation of the tangent line. So the tangent line is this line. It's a vertical line, which means it's undefined, which means we cannot use y equals. This is an x equals, and x equals 3. Our next example, we want to find the radius of circle M. So again, from the center of M to the side, it's 1 unit. Radius of circle N, from the center to the side, that's 2 units. Point of tangency, it's where the circles and the tangent line meet up. It's right here at -2, 0. Then we want the equation of the tangent line. The tangent line is a vertical line, which is undefined slope, which means that we cannot use y equals. We have to have x equals, and x equals -2. Our next theorem says that when you have 2 segments of tangents that touch the circle and intersect at the same exterior point, these 2 tangent segments are the same length. So one segment AC is congruent to segment AB. So our next example uses that theorem. We have segment DE and segment DF that are tangent segments to circle C. And we want to find the length of DF. So we have that 5y minus 28 equals 3y. Because these are tangent segments to the same circle and they intersect at D. We're going to subtract 5y from both sides. That gets us -28 equaling -2y. We're going to divide both sides by -2. And y equals 14. Now, we are not finished because it asked us to find the measure of DF. So DF was 3y. So we're plugging that 14 in for y. So we've got 3 times 14, which is 42 for the length of DF. Next up, a central angle is an angle that has its vertex at the center of a circle. An arc is an unbroken piece of the outside of the circle, And it consists of two endpoints and all of the points in between those two endpoints. Okay, so what I mean by that is this red here is an arc. It's arc AC, and it's a minor arc. And this minor arc measures the same thing as this central angle. So that means that angle ABC and arc AC both measure X degrees, whatever that central angle equals. A major arc is greater than 180 degrees. So it equals 360 degrees minus this smaller central angle. You can find it by adding everything there together if you have multiple pieces. Again, it's greater than 180 degrees. And as you'll notice here, when we name major arcs, they're named with 3 points. And we go A, D, C around the circle. Shortest way from one point to the next. From A around to D to C. So I didn't go A to D this way and then back to C. You go around the circle without having to go back on yourself. So you'll notice that that minor arc above, we just use 2 letters to name it. It's arc AC. And then we have semicircles. So semicircles are made from diameters, meaning that the circle is getting cut in half. And semicircles measure 180 degrees. That's why it's important that major arcs are greater than 180 degrees. That means that central angles or minor arcs are going to be less than 180 degrees. So that means that arc EFG equals 180 degrees. Again, semicircles are named with 3 points. So you can tell by how they're named whether they are less than 180 degrees or equal to or greater than 180 degrees. The ones that are less than 180 degrees have 2 points and they're minor arcs. The ones that are greater than 180 degrees or equal to 180 degrees are major arcs and semicircles. So I highly recommend finding out what each piece or angle equals. So we can start off with this box right here. It's a right angle box. It means that arc CD equals 90 degrees and angle CFD equals 90 degrees. Then we can go to this angle here, angle BFA and angle DFE are vertical angles. And remember that vertical angles are congruent. So that means that angle DFE or arc DE are 18 degrees. Then for arc AE or angle AFE, we know that AD is a diameter, which means that arc AED is a semicircle, which means it equals 180 degrees, and we can subtract 18 from it to find arc AE. And that gets us 162 degrees. So for the last one, we have a couple options. We could add everything here together, subtract it from 360 to get this, or we know that this is 90 degrees, and this has to be 90 degrees because AD is a diameter. So that means that AB plus BC together have to be 90 degrees. So we can take 90 minus 18 and get 72 degrees. Now that we found everything, we can look for our arcs. So arc CE. So C to E going the shortest way around. So I'm not going to go left. I'm going to go right to E. So we add 90 and 18 together. And that gets us 108 degrees for the measure of arc CE. Our next one we're looking for is the measure of arc AE. So A to E going the shortest way means that I'm going to the right. And that is just one that we've already found. It's 162 degrees.